do this. Do it fast. Hello everyone, January the 6th. Alright, just ate and I need to digest a little bit, then I can go train. Oh, great, we have an easy problem. Perfect. I'll do this and I'll try to prove this. Okay, I solved this problem yesterday, but the proof was, I didn't have time to actually prove anything, so I want to give the proof a little shot. But let's first check today. String matching in array. All right, I'm gonna switch this back to C++. Given an array of string words, return all strings in words that is a substring of another word. You can return the answer in any order. Return all strings in words that is a substring of another word. Okay, so as is mass, hero is a substring of superhero. How we do this? I mean, yeah, I see it's gonna be brute force, but I wonder if there's another way to not brute force this. Is it possible to not brute force this? I'm thinking about like a trie, but if it's a trie, how do you tell if it's a substring, right? Huh? Interesting question. Interesting question. We need to know if it's a substring of another string. I mean, the only thing you can do is matching. You do like a two-pointer thing, right? The smaller one is going to be trying to match the bigger one. Okay, how about we sort words based on their size? Okay, so now the smaller one will check against all the other bigger ones, and then and then we just keep going. That will be on times, but each check have to go through the entire thing. All right, I think I'm gonna go just brute force this. C++ string contain. Does it have this? Find. So s1.find s2. If s2 is a substring of s1. Okay. Well, let's do it then. We just brute force this. There probably is a better way, but let's first brute force. Okay, we brute force it, and then we'll deal with the other scenario. So if I brute force this, I first of all require a res, and then we say I 0i smaller than was dot size I plus plus, right? And then for int j is equal to I plus 1, j smaller than was dot size, j plus. We just basically go through every single one, and we say if what's I. Oh, then you have to do it twice. How about we sort it first? Right, we can do sort. words dot begin, words dot and I believe we can say a string b return a dot size smaller b dot size. I think that is the sort. Okay, and then we can say if words j dot find words I, if it's not equal to std string dot no ops. Actually, I don't know what was this say. String no op. If it's not no ops, then we say rest dot push back words I. I is a smaller one, and then in the end we return rest. All right. I'll give this a shot. That looks about right. I mean, yeah, for sure this will work, but it's just brute force. (1408). This is a brute force. We call it MN, right? Actually, no. Oh my god, this is n squared, right? Because this one is n squared times m. You say where n is the length of the words, and m is the I don't know. I say average length of each word, something like that. All right, let's submit it. That is interesting. We're missing one. How is that possible? Did we not sort it correct? Which one are we missing? O, D, O. I have a duplicate. How is that possible? We have a duplicate. OD, so OD come out. Oh, shoot. My bad. Damn. It could be, as long as it's one, then we should break it out. Damn. Yep, my bad. We shall break it out. Because it become the substring. Alright, to use this test case, we'll run it again. Wow, that's oversight. Okay, so brute force is here. Definitely there is room for improvement. 4 milliseconds, 39.92. 31.92, yeah, 31.92. Alright, so now it's time to think. How can we make it faster? Substring. There's some matching that we can do, like we can use a counter, but use a counter. I'm not sure about that. Because it's going to take time to get a counter. So what we're trying to say is if there's a way to not go through all pairs, oh, I see. I think we can. No. It is like. Then we move on to the next one, right? Yeah, this is fine. This is fine. Actually, I don't know. Do we have a hint for this? Oh, KMP. But KMP is just to find substring. Right? KMP is just to find substring. But still, it's still brute force, right? You still have to use brute force. I am not building a KMP for this. I mean, I am hoping that this is a KMP, right? This find. But we're not doing KMP for this. Because KMP you need to compute the LPS longest prefix suffix array. Do you still remember how KMP goes? KMP is to find the longest prefix suffix array. I forgot what LPS stands for. So it's a target, right? It's a target. And then we have the current length, and then we say current index is equal to, it's like ending at here. At this point, what's the longest prefix that's equal to the suffix? Yeah, longest the prefix that's equal to the suffix, right? Longest prefix that's equal to the suffix. So at each we have that, and then once we build this LPS, and then we are matching, right? As we are matching, we have, so yeah, if it's match, as whenever we have a mismatch, right? Whenever we have a mismatch, instead of going back to the start, we can say we have the suffix, prefix suffix, right? How much we match. So the front and the end match. Then we can just jump that much forward, right? And then we can keep, yeah, I think I understand. I think I know. Blah, blah, blah. Else if it's not the same, right? So basically we have a prefix and a suffix we're matching. If the current index is equal to the previous length, then LPS current index is equal to length, current index move forward. And then if there's a mismatch, if length larger than 0, basically we say this and this is mismatch, then the length at this point shall be LPS line minus 1, which is going to the previous, right? Because we're saying at this point, these two are now the same. So now, at this point, the LPS will be the one before, right? And then we try it again. If it's not good, we try it again until at a point ln becomes 0. And then we just move forward. And ln becomes 0, that basically we don't have anything to match, so it's going to be 0. So move current index, move forward. Okay, yeah, I understand that. Now we're trying to match. If it's equal, we move forward. If it's, yep, we found the match. Otherwise, if it's a not, then sub index is larger than 0. Yes. I use LPS to skip unnecessary comparison. Yes, we say the sub index equal to this. Yes. And if sub index is equal to 0, that means we are at the front of the substring, so there's no more to match. And in that case, we move this one forward. Yep, I can understand. KMP. I think this is, I don't know how many times I've gone through KMP. I understand. If you ask me to write it from scratch, I think I can just get it out, but it will take a lot of efforts. All right, there is a try that we can try. A suffix try. A suffix try. How do you do a suffix try? All the suffixes. So basically we go from right to left, okay? All right, we can build a try. But then what? But then what? Every word and insert each suffix into the try. So it's a big try, so we put all the suffix. To insert a string word in the try, we start from the root, which is this, yes. Yes, after inserting all suffix into the word, all suffixes, which means it's not a word, but a suffix. I think what it's trying to say is we insert S, SS, SSA, SSAM. I think that's what it means. No, I think what it means is do this. Actually, hold on. Let me see what it means. I think it means is we do MASS, ASS, SS, and S. Because that's all the substring. Right? That's all the substrings start from different position. And then we'll put A and AS, we'll put H. Actually, no, AS and then S. We put this, we put this, and we put this. We put this. And then all the superhero stuff. So now we have the try. Then we go to mass. Right, we go to mass. We're going to find if it's a substring of somebody. And we just go through this. But if it ends at the same, if it ends as a word, then this is not a match, right? If it ends, we don't have another thing going on. But if it's AS, I mean AS is here, but this is also a. Where is AS? Yeah, this is, we have AS here, which means when we match AS in the try, we can have A, we have an S, and there's something more. So that's why AS is correct. I think I know what to try to do. Let's just finish reading, see if it's correct. Okay, we have a try. We can also see how they make try. So we have a try node. Okay, try node. How many times the substring appears in the try? Oh, that is smart. That is actually very smart. We can just set it to a number, and then we have unordered map character, and then we have a new try. That's good. And insert word. insert the frequency of the node. Yes. Else, I have a new node. Frequency is 1. Yes. Okay. So now for each, we have start, we have a substring. There we go. This is where we do substring. I mean, if we already do substring, we might as well just find this. I mean, actually, I just realized, what if I don't sort? You know, you don't sort and you just go from start. I think this will also work. Ooh, it does not work. Huh, it does not work. Oh, we have to say if I is not equal to j. I is not equal to j. Yeah. Without sorting. It's the same. It's the same. Yeah, so insert word is indeed like 0 to the end, and this to the end, this to the end. And then we check is substring. Basically, you go through the try, and then if the frequency is larger than 1. Actually, the try method is pretty smart. I actually like it. Okay, that'll be it. And it's 9 o'clock, so I will go for my training session. Let's upvote this and then go for the training session. Alright, that'll be it for today. I'll see you guys tomorrow. Adios.